Okay, a little explanation of binomial theorem. Basically, it's used to find the k plus first term of a plus b to the n. And the theorem tells us that that term is based on doing n factorial over n minus k factorial, a to the n minus k, b to the k. All right? What that means is if I'm finding the k plus first term, I start off doing the b, and that's always to the one less. If I want k plus first, I do b to the k. If I want the 10th term, I do b to the 9th. If I want the 15th term, I do b to the 14th. So that is always one less. And that's basically what I use in remembering the binomial theorem. I know I'm going to have a fraction with factorials. Then I'm going to have the two parts of the binomial raised to different exponents based on the term. If I want the fourth term, this exponent is always one less. Well, what's one less than 4? 3. Then this one, these two terms always have to add up to the binomial that I'm expanding. So in this case, 12. So what plus 3 equals 12? How about 9? Okay. What goes in these parentheses? Second one gets a y, first one gets a x, based on what was first and what was second here. Now, this factorial combination, the top factorial is always the exponent that you started with. 12 factorial. The two bottom factorials are the 9 and the 3. 9 factorial, 3 factorial. By definition, they're the k and the n minus k. Or the 3, and then the 12 minus 3, which is 9. Now, the expansion for the fourth term, I just simplify that. So I know I'm going to have x to the 9th, y to the 3rd. That part was easy, right? But what about this? I need to expand this. So let's do a little work here. 12 factorial means 12 times 11 times 10 times 9 times 8 times 7 all the way down to 1. On the top here I have 9 factorial, 9 times 8 times 7 times 6 times 5 all the way down to 1. And I also have 3 times 2 times 1. I'll write the shorter one in the front. Now notice if this is going 9 all the way to 1 and this one's going 9 all the way to 1, I can cross those out because they're going to reduce with each other. So now all I have to deal with is this. So I could do, well, 3 times 2 is 6. 6 goes into 12 2 times. 1 I don't have to worry about. So the coefficient here becomes 2 times 11 is 22 times 10, 220. And there we have the coefficient of the fourth term. All right, let's try another term. Hold on, let me erase my book. All right, I've changed this a little bit. In fact, I'm going to change it a little bit more. Instead of just a y there, we're going to make it a 2y. All right? Ooh, let's make it even trickier. Let's make it a minus 2y. So x minus 2y, and it's to the 15th power. And I want the 8th term. So, remember I told you how to set it up? Make a fraction bar and 2 parentheses. So if I want the 8th term, the exponent in this term is 1 less than 8. So what's it going to be? 7. Okay. What exponent goes here? Well, 15 has to be the total sum of these two exponents. So how about an 8? 7 and 8. Does that add to 15? Oh yeah. Now I need to do what goes inside of this? X. What goes in here? Minus 2y. All right, let's do the factorials for the major part of the coefficient. Do you remember what factorial goes on top? 15. Okay, so to finish this out with the binomial theorem, basically I just have to simplify this. One tricky part I'm going to do first is 2 to the 7th, or minus 2 to the 7th. So get out the trusty calculator there and do 2 to the 7th. 128. Now, is that going to be positive or negative? Hope you realize negative 128 there for that one. All right. Now, I need to simplify this stuff, so I'm going to put a new fraction bar over here. 15 factorial means 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8. I'm going to stop for a minute. You know that goes 8 all the way down to 1. And then I have 7 factorial and 8 factorial here. Well, 8 factorial is 8 all the way to 1. So I'm going to cross that out with this to save some writing here. Now I'm going to rewrite the 7 factorial as 7 times 6 times 5 times 4 times 3 times 2 times 1. And we're going to start reducing. So 7 goes into 14 2 times. 6 goes into 12 2 times. 5 goes into 10 2 times. How about 2 goes into 4 2 times and into that 2. All right, another 2 right there. How about this 2 with that 2? I still have this 3 into 15 is 5. All right, so let's multiply what we have left. I've got a 5, a 13, 11, a 9, and a negative 128. So my final answer is going to have an x to the 8th, a y to the 7th, and then some coefficient here. And that coefficient is these numbers multiplied out. So let's get the trusty old calculator and do that. I have 5 times 13 times 11 times 9 times 128, and I get 823,680. Positive or negative? Negative. All right, we're going to double check that just to make sure. So always do these twice. 5 times 13 times 11 times 9 times negative 128, 823,680. So we got it. So final answer for the binomial theorem is negative 823,680, x to the 8th, y to the 7th. And that was for which term? The 8th term. The 8th term starts with 1 less here. These two exponents have to add up to a 15. And hopefully I did my arithmetic right. So there you go. Good luck.